Okay, so we are going to start with adding and subtracting polynomials. Okay, first of all, we're going to start off. Don't get all wrapped up in the word polynomial. Don't let that scare you. You have been dealing with monomials and binomials this entire time. We just never called it that. So the definition of a monomial is a number, a variable, or the product, which means multiplication, of numbers and variables. So 5 is a monomial because it is a number. X is a monomial because it is a variable. Or negative 4x squared y is a monomial because it's a product, meaning multiplication, of numbers and variables. So there are 3 examples of monomials. The polynomial is basically like a big umbrella over everything else. The definition of polynomial it is a monomial or the sum of monomials. Again, do not get all wrapped up in the word sum, because sum can also be written with subtraction. So 5 plus 3 is the same thing as 5 minus a negative 3. So subtraction and addition can be written inversely. What you're looking for is they are going to be separated by addition or subtraction signs. Okay? If you have 2 monomials that you cannot combine, such as 5 plus x, that is called a binomial. Three monomials, so like x squared minus 3x plus 1, that would be called a trinomial. Anything beyond that, we just simply call a 4-termed polynomial or a 5-termed polynomial, etc. We have also what are called degrees of monomials. It is the sum of the exponents on the variables. Make sure that you're adding the exponents on the variables. So if we have 4x squared y, if I'm looking at degree, I do not count any exponents on the 4 because it's a number. I have 2 there and I have an understood 1 there, which means that this is a 3rd degree, which means that it is also called a cubic. -8, it does not have any variables, So this is a 0 degree, and it's called a constant. Negative 4xy. Again, we have understood exponents on the variables. Do not look at the understood 1 on the negative 4. So I have 1, 2, which means this is a second degree, which is called a quadratic. And if I have 7x, I have an understood 1. This is a first degree, which is called a linear. If you remember from the very beginning of algebra, we talked about like terms. So I could add 2x plus 4x and get 6x. They both have the same variable raised to the same power. If I have 3x squared plus x to the 4th, I cannot do anything with that because these are not like terms. I have the same variable, but they are not raised to the same power. So this would be my answer. So when you are combining like terms, you have to make sure that you have the same variable raised to the same power. Okay, so if we are adding and subtracting polynomials, typically we write it in standard form or leave answers in standard form. And a lot of times I'll refer to that as descending order. So if I am looking at my degrees, if I have 2x to the 5th minus 7x to the 7th plus 3x minus 4x squared plus 6, that is not in descending order as of right now. So I'm going to look at my highest degree. I have a 5, a 7, an understood 1, a 2, and an understood 0. The 0 is not on the 6. It is on a variable with a understood 0. So 7 would be the highest one, so this whole term would be first, so negative 7x to the 7th. Next I have a 5, it is a positive 2x to the 5th. I then have 4x squared, which is a negative 4x squared, positive 3x, and then a positive 6. That would be descending order, so you don't have to have every single power represented, but it just has to go in descending order. 7, 5, 2, 1, and a 0. So if we are going to find the sum, if we have 6x squared minus x plus 3 plus negative 2x plus x squared minus 7. The first thing you need to be looking for is what is going on in between the parentheses. Is it adding, is it subtracting, or is it multiplying? We are adding, so this does not affect anything to the right. So I have 6x squared minus x plus 3. Nothing changes here because I'm just adding it. Minus 2x plus x squared minus 7. Now I can combine like terms. 6x squared plus another understood 1x squared gives me 7x squareds. Negative x minus 2x. I look at the coefficients and I end up with a negative 3x. 3 minus 7 gives me a negative 4. That's what happens if you are adding. If I want to find the difference, we have negative 6x to the third plus 5x minus 3 minus the quantity of 2x to the third plus 4x squared minus 3x plus 1. It really does help if you think of this as the distributive property. I am subtracting everything, or you can look at it that there is an understood 1 there, so I have to use the distributive property to every single term to the right. This does nothing to the quantity in front. So negative 6x to the third plus 5x minus 3, nothing changes there. But this negative 1 being distributed changes every term to the opposite sign. So this is a positive 2x cubed. It is now going to be a negative 2x cubed. Positive 4x squared, it's now a negative 4x squared. Negative 3x is now a positive 3x, and then we have a negative 1. Combining like terms, I'm looking at my cubes first, because it's the largest. Negative 6 minus 2 gives me a negative 8x cubed. I have just the negative 4x squared. I have a positive 5x and a positive 3x gives me a positive 8x. And finally, negative 3 minus 1 gives me a negative 4. Okay, so we are going to try a couple problems as a warm-up. So give these a try before tomorrow morning. So warm-up. Let's do the quantity of 5 r to the third plus 8 plus 6r to the third minus 3, and a second warm-up of x squared minus 2 minus 3x plus 5. Give both of those a try before tomorrow morning.